you might give Mike the microphone. Give Mike the mic when I'm working on this. All right, so I printed out the official bio. I'm going to read it to you now. I'm just kidding. So this is Mike Franklin. I'll get to a relationship in a moment, but he's a professor of, Thomas M. Siebel Professor of Computer Science at UC Berkeley. He's the director of the AMPLab, and this is actually, where he's going to spend a lot of his talk. He's also a former founder and CTO of Truviso, which was doing real-time analytics and got bought off by Cisco. So, he knows a lot about both sides of the interaction between industry and academia. Now, the official bio lists, in the last handful of years, it lists like 5 best-of awards, and ignores everything that came before that. So, he's done well at research as well. And then, sort of at the bottom of the bio, it says that he received his PhD in '93, and we just realized that actually 20 years ago. And in '93, he joined University of Maryland College Park as a new faculty member, and I joined the University of Maryland College Park as a new graduate student. And I hadn't actually learned any real databases in my undergraduate, and I was told that I should take this course with this new professor. He might be a good, speaker. And I joined the course and decided that was my research area. And got involved, started working with him, and became his first PhD student. Apparently, after that experience, he had enough and went to Berkeley. So I don't know what's up with that, but it's really a pleasure to have Mike here. I'm glad to be, after 20 years, to finally get him to come to Iceland, and really, we found a good reason to get him here. So welcome.
All right, thank you. All right, I'm going to try this. If this doesn't work, I'll switch to the Britney Spears thing. But so first of all, thank you very much for having me here. There's an important lesson already for the students in the audience, which is basically you can never get rid of your advisor. So you should just keep that in mind. All right, so let's see. That's yours. I probably need to find mine. And since it's a Windows machine, I'm a little lost.
Let's see if we can do this.
Oh, okay.
Okay.
All right. Let's see. Let's see. Okay. So, one more thing I got to do is figure out how to put it into slideshow. Oh, okay. Great. Well, I'm going to go through this fast because I actually have a different title up here than the one I told you guys. Okay. So here's what I want to do. Basically, I think it's great that you're starting the center, and I'd wanted to come visit for a long time, but when Jordan told me the reason for this particular event, I said, all right, well, if we're ever going to do it, this is the time to do it, because at Berkeley we've been working over a bunch of years trying to come up with models that basically let us kind of extend our footprint and have more impact than you might think you would be able to have working at a university. And we've been pretty successful. I won't take credit for this. I'll show you in a second. It's been done for a long time. But I want to tell you about this model. The key components really are you got to set goals. There's a bunch of things you got to do for organizing to improve collaboration. You guys are off to a good start on that. And then, sort of how do you engage with all the various communities you need to engage with. Now, Berkeley has some advantages. It's a lot bigger. It's really close to this interesting place called Silicon Valley. So, there's some things that are going to translate better than others. But I do think that, I'll tell you what we've done and what we've learned, and you guys need to figure out, just like a PhD student does, what to listen to, what to ignore, and, hopefully some of the things will stick. Okay, so I'll just show this briefly. This is Dave Patterson's slide. So those of you in research probably know who Dave Patterson is. He did a few small projects like invented RAID storage, invented RISC processes. He's one of the guys in the lab. And this is a list of projects that he was involved in. that sort of started this model. And you can see it goes back into sort of the 70s. And some of these you've heard of and some of them you haven't. And that's one of the points, which is, you start off on a project and it's research, and, sometimes it works out really great. Sometimes it works out better than you expected, and sometimes, it's time to move on to the next project. So, but what you can see here is there's been kind of a steady growth in the magnitude of these projects, and kind of the current set of these things is really running at a pretty large size now. Our lab and the lab that started before us have 9 faculty involved. And anyway, I'll drill down more on this, but basically, this is just kind of showing that there's a long history of these things, and the model's evolved over time. So what I want to do is tell you a little bit about the AMPLab, because that's the example I want to give, and it's what I've been spending all my time working on lately. And then I'm going to kind of focus on some of the key parts of this lab model that seem to have contributed to the success we've been able to have. And then I'll wrap up. So try to make sure I don't extend into the reception. So what's the AMPLab? So the AMPLab is a big data project, and we started it. It officially launched January 2011. We did the groundwork. I'll give you a little bit more of the history, but it took a couple years to get the thing started. So when we started, we didn't even use the term big data. It was kind of floating around, but it hadn't really caught on yet. Now we use it kind of, it's kind of embarrassing how much we use it. But, we were fortunate, and I think there was a little more than fortune than luck involved. But we were lucky, I'll say, to sort of get started on this project before the big data wave hit. And sort of we were, right there at the right time. And, so why are people excited about big data? Why is this such a phenomenon right now? And, the reason is, and, to put it kind of quickly, is that, big data is everywhere. So if you look at where the volumes of data are increasing and where all the interesting data is coming from, these are kind of 4 areas that I highlight. And, basically, kind of going clockwise, all online activity generates data. You click on a web page, that generates a log record for that. When you bring up that web page, there are, dozens, literally, of beacons and other things on that web page that basically let the whole world know that you clicked on that web page. At each of those places it finds out about it, there's all sorts of other log records that get generated in terms of what different servers are doing, what's happening in the network, and so on. Okay, so that act of one little click generates this huge cascade of data. Okay, and so when you hear about terabytes of data a day being generated by web companies, that's just the tip of the iceberg. Okay, the second area is user-generated content. So some of that is just tweets and blogs and things like that. Others are video and images and so on. Okay, and so that's another type of data. It's different in some ways than this log-generated data, but also a source of interesting big data. I guess I'm not going to go clockwise. Over here is machine-to-machine. So there's been a lot of talk recently about the Internet of Things, the Internet of Everything. Somebody, if you want to go one up on the Internet of Things. And the industrial internet, there's a bunch of different names that this has been going by. But the fundamental idea is that as we carry more software around with us, as the devices out in the world become intelligent and become connected to the network, they're able to collect data, to generate data, and then to basically exchange that data. And so while the first 2 places where big data are coming from are kind of driven by people, by the number of people in the world that are connected, machine-to-machine doesn't have that problem. And so I think in the long run, in terms of volume, that's going to be a huge source of data. And then finally, basically all science is turned into, that's kind of a strong statement, but most sciences are turning into data analysis exercises. So, somebody collects the data and then lots of people look at it and try to make sense of it. And what this curve is showing is kind of interesting if you haven't seen this before. This is a log scale, and that straight line that doesn't look that interesting, that's Moore's law. Okay, so that's, what we in computer science have been living off of for all these years of, things getting better by a factor of 2 every 18 months. Okay, and we were pretty excited about that. That curve that's dropping like a rock, that's the cost of sequencing genomes. Okay, and so basically, if you're doing genomics work, your computers are getting that much slower every year. Okay, and so, and that's just one example. So this is why there's so much excitement about big data, all right? Because it's all these different areas are generating lots of data, and they're becoming, driven by that data. So from a technical point of view, what's interesting about it? So first of all, big data, there's a lot of it, right? That's where the name comes from. And this graph is just sort of showing what I just told you. That lowest curve, the gray one, is Moore's law, and then there's different sources of data. The green line is sort of all data, and that's just according to, I guess, IDC, that's growing somewhat faster than Moore's law. But then in certain areas, especially in the sciences, it's growing much faster than Moore's law. Okay, so one problem is that you've got a lot of data to deal with, and that's breaking the traditional systems. The second is that data's coming from all over the place. So it's dirty, it's incomplete. When you take data from multiple sources and try to put it together, it doesn't match up very well. A lot of times there's data sitting out somewhere and you're not really sure where it came from or how it's organized. And people want to make sense of all this information. Okay, so that's the second problem, is that the data's dirty. And that the third problem is that the questions people are asking, as we're providing the ability to access all this information, the questions people are asking are becoming more difficult. So a lot of questions are sort of predictive in nature. Like if I were to build this new highway off-ramp, what would that do to traffic, right? That's an obvious question you might want to ask. But what's it going to do to economic development, around that area? Or what's it going to do to economic development in some other part of the city? Okay, those are the kinds of questions people want to ask. That's a lot different. It's hard to write the SQL query for those. Okay? Real time, people are putting much more, they're making decisions, and they're having to make decisions faster and faster. So there's a big emphasis on lowering the latency, getting answers quicker. And then finally, a lot of questions are sort of open-ended. They're not particularly well specified. Bjorn mentioned that I had started an analytics company. I would go to meet with potential customers and we'd talk about what their needs were and what they wanted to do. And I realized the number one question that everybody wanted to answer was, tell me what's interesting in my data, right? If you could answer that query, you were going to get lots of customers. So on the data side, we've got this problem that things are getting bigger. We've got the problem that data is coming from all over the place and it's messy. And then we have this increase in the demands from the kind of the user side. Okay? And when you put all these together, basically what that means is that the existing infrastructures that we've built for data management, for doing query processing and business intelligence over the past 30 years or so, we don't think those are going to, they're not going to cut it to solve this new class of problems. So a lot of times when I tell people I'm working in big data, they ask me, is this really something different, or is this just sort of a scaling up of what existed before? And for all those reasons, I think when you put all that together, you can make the argument that it's really different. And so the way we're attacking it in the AMPLab is really where the name of the lab comes from, is that we believe that there are sort of three main resources that you have available to make sense of data. Algorithms in the form of statistical machine learning and other types of analytics. Machines in the form of large clusters of computers and cloud computing, where you can get new resources when you need them and give them up when you don't need them. And the third component is people. And so we want to look at how do you include people in the entire analytics lifecycle. So you have analysts that are looking at data and trying to understand it. You have places where existing machine learning and other algorithms can't get you the right answer because the data is really dirty or messy, there's ambiguity in the questions. Oftentimes people are really good at dealing with ambiguity, right, and doing pattern recognition and things that we still can't get algorithms to do with 100% accuracy. And so the idea is, how do we bring people into the analytics process as well? And our argument is that if you want to do this, if you really want to integrate these three types of resources that are very different, you need a new architecture. And it's got to be a new architecture that not any one of those groups that we saw at CRESS is going to come up with, right? It's not just a systems problem. It's not just an HCI problem, right? It's not just a formal methods problem. Might just be a data problem. But, that's you got to put it all together, okay? And so that's why I wanted to walk you through that, just so you understand kind of the scope of what we're trying to do. So we've got 9 professors, and I'll tell you a little bit more about it. But you can see where we come from. It's systems, databases, machine learning, crowdsourcing, and so on. We take these people and a bunch of students, and we put them in a shared lab. So you can't really see in this picture very well, but these are not walls. They're just desks with kind of very low walls. So it's a very big open space, okay, that we all sit in. I'll tell you more about that. We launched it, like I said earlier, beginning of 2011. And when we started, we said it was going to be a 5-year project, and that's part of the plan too. That's had a little change, but I'll explain that in a second as well. Okay, so that's really what the AMPLab is. It's about 60 people all told. All right. One of the reasons I'm here is because a key part of the AMPLab and this model that has been developed for labs is to try to get companies involved really at the early stages, even before the project gets launched. And so when we started the project, first company I approached was Google. And my motivation for that was simply that I figured if there was any company that was going to tell me that they already had the problem solved, it would be Google. So, I figured if I could convince them that there was something we could do that they weren't doing, we could probably convince most anybody. And sure enough, we told them our ideas. I gave them a longer version of the pitch I just gave you. And, they agreed pretty quickly to be a major sponsor of the lab. Shortly after that, SAP joined as a major sponsor, and then shortly after that, Amazon Web Services, which is a big cloud provider, decided to join at that level. And, once we had that going, it became a lot easier to get other companies to join. And so if you look at this list of companies, you'll see a lot of interesting things. You'll see big companies and small companies. You'll see companies from the U.S., from Asia, from Europe. You'll see companies that do databases, networking, storage, systems. And the other thing you'll see, which is kind of interesting, is you'll see a lot of companies that don't like each other. That's part of the I think the value add that we bring to the table in this model is we're sort of a nice neutral place for people to get together and talk about research in this area. Okay, so this is our current set of sponsors, and I'll tell you how we work with these sponsors, in just a little bit. Our original plan when we started the lab was to fund it completely from industry sponsorships, and the reason we did that is because at the time we were having these discussions, 2009, I guess we started, so you guys were dealing with your own issues, but we were having trouble getting funding from the federal government to do computer science research. There was a previous administration that sort of felt that this was a job of industry. There were lots of software companies out there, and so why should we fund researchers to do this sort of stuff? And so it wasn't a very good government funding climate. So we thought we would just do it from industry support. There was this interesting program from the National Science Foundation called Expeditions in Computing that were 5 years, $2 million a year. And they were meant for big collaborations. We were a big collaboration, so we said, all right, well, why don't we try it? And, again, it's sort of just, it's kind of luck. We put together the proposal, we sent it in. It's about a 1.5-year process where they, accept pre-proposals, and then a small number of those they ask for full proposals, and then some small percentages of those they invite to go to Washington and present. And, it gets winnowed down until they pick 3 winners, and they do this every 2 years. And we put ours in. It was a pretty good proposal, I think. And, sorry, I was supposed to highlight this. And we went through the process, and just as they were making the final decisions of who was going to get this award, the White House came out and said, hey, this big data thing is really important. We want to encourage federal investment in research in this area because we think it's a critical technology that needs to be done not only in industry but also in academia. So, I mean, perfect timing. All the government agencies were scrambling, looking for big data projects to fund. We had this big proposal in for big data, and the timing worked out. So I got to go to Washington and shake hands with people, and we got this nice award. So, where we ended up roughly, I think I have another. Oh, sorry. Where we ended up is we're about 50-50 funded now, from half industry, half government. And that turns out to be really good because I'll tell you, we get a lot of benefits from the industry funding, a lot of flexibility. But the problem is companies basically fund us, except for those major ones I told you about. It's basically a year-to-year thing, right, because companies have their budget cycles that they have to go through. And so the federal funding gives us some longer-term support, even though it's kind of focused on, it's in buckets. We have to spend it on students and specific things. But it's that combination that gives us, some amount of assurance that we can, so that when we promise a PhD student that we'll fund them for 5 years, we actually have some hope that we'll have the money to do so. And then, the industry funding lets us do the other stuff we like to do, which I'll tell you about. All right, so that's kind of where we ended up. And, how has this worked? So we started in January 2011, so we're, a little less than 3 years into it. And we've done a bunch of things. So we've released a lot of software. I'll tell you about this. It's called the Berkeley Data Analytics Stack, BDAS. And one of the tenets of our lab is we release as much open source as we can. So here are 3 systems that we've released so far. Mesos is a cluster virtualization layer. It's very bottom of the stack. It's in use at a lot of companies. The one that's been the most vocal about it is Twitter, which has been running it on 6,000 servers. And there was a really interesting article in Wired magazine about how they used Mesos to build their new infrastructure. Now, what's interesting about that is, if you notice, the title of that article is about Twitter rebuilding Google's secret weapon. So when this article came out, when I saw that title, I'm like, oh no. Because here's one of our major sponsors, Google, and this other company goes ahead and takes open source software that we built and builds what Wired says is this competitor. But actually, if you read that article, one of the main people that they interview in that article is a guy from Google, and he explains the interaction that our group had with his group. And, that basically, yes, Twitter has been able to use this stuff to get somewhere with it, and that's good. But, of course, Google thinks they're already way ahead of that. And, in fact, the interaction between our group and their group, helped influence their next generation design. So it was actually a pretty happy article, even, from that perspective. So that's Mesos. Spark and Shark, I'll say a little bit about, but if you know about Hadoop, it's a system for processing big data. Spark and Shark are alternatives, let's say, to Hadoop. And they have some advantages in performance, and they've gotten huge uptake. I'll tell you about that as well. So we've been able to release software through open source that's been very influential, and that's a big part of the message I want give today, so I'll say it now and then I'll say it later, which is, academics used to have an excuse, right? We used to say, well, we can't really do that because we're not a company and we can't really build software, and even if we did, nobody would use it. And that's just not true. If it was ever true, it's certainly not true anymore. If you're working on an interesting problem and you put something out in open source, and you get a little bit of interest in it, you blog or you get somebody to blog or you do something about it, you put the right keywords in your description, somebody's going to try it. And if it works, they're going to tell other people about it. And it's this chance to have, real influence and real impact. And not have to, and I apologize to any of the companies in the audience, but not have to go to the companies and say, hey, look at my great idea, why don't you try to implement it, right? And so I think open source has really changed what, centers like CRESS and labs like mine can think about doing. So that's why I want to mention it. As Björn said, it's not like we're just building software. We've been doing great research. We've been winning best paper awards kind of left and right. And so, and our students that build this stuff and that do this research, as you can imagine, are in crazy high demand, both in industry and in academia. So I feel like we've somehow been able to balance the practical side of what we do and maybe the more research-oriented side. So we can talk about how you might do that. We've had some successful applications. We've done some work with a group on campus that does traffic monitoring and prediction and helps scale up their stuff. We built an application for doing cell phone energy monitoring and prediction, and that's actually gotten quite a bit of uptake. 650,000 downloads last time we checked. And so we've had some successes in the application side. And then we do a lot of outreach, which I'll tell you about, too, as part of the methodology. So just briefly, there was, like I showed you that long list. We're not the first one of these. We've kind of been able to benefit from a lot of the previous projects and tweak their model a little bit. So there was a previous model that ended in a previous lab that ended in 2010. That was called the RAD Lab, and it was focused on cloud computing. In the middle of that lab, me and one of the other professors took a 2-year leave of absence. I went off and started my analytics company. He went off and started a video distribution company. And, we were both out talking to potential customers, talking to users, looking at what's going on. And when we both got back in 2009 from our leaves, we were talking, and we had both seen the same thing, right? We saw the big data thing coming, before it really hit. And so, for the administrators in the audience, I can't overemphasize the importance of making sure that faculty get the chance to go out and, interact with what's going on in industry, because, that's how you keep grounded, and that's how you see what's coming. So, we had a lot of discussions about what to do next, and, we came up with this, AMP thing that I told you about, and then I told you the story about how we went out and started getting funding for it. And we launched the lab in 2011, and then we said, okay, we're going to work on this for 5 years, and then we're going to stop. A year into it, we got a 5-year grant. So we said, all right, well, we'll work on it for 5 years, and then we'll stop. So now it's a 6-year project. But we're still going to stop. So, and I'll tell you how that works in a second. And, since that time, we've been able to, get the DARPA X-Data program is another thing that came out of the White House initiative. They're trying to build a common open source analytics platform for the U.S. government, at least the Department of Defense. And then, I showed you a bunch of our other sponsors. Okay, so what I want to do, and don't worry about it, this isn't to scale. I kind of told you about the AMPLab and what it is. And so now you understand, hopefully, a little bit more about where I'm coming from. So now what I want to do is kind of drill down on a couple key components of how we put the lab together, to sort of explain the model. All right, and then I'll just wrap up. Okay, so let me look at that list again. Okay, so so problem selection and goals. So let me just build this. Oh, sorry. So again, this is sort of from the collective experience of that long list of projects I showed you, not just from the AMPLab. So the first one is, it's really good if you can find a problem that other people care about, that, that somebody cares about, okay? And, in the case of the AMPLab, I told you how me and one of the other faculty members had been out in industry and saw what industry was worried about. But it doesn't have to be industry, right? Maybe there's a scientist that that's got a problem that they're trying to solve, or maybe there's a government agency that that has a problem that they're trying to solve, or maybe there's somebody else in your department that's got a problem that they're trying to solve. But the idea is, if you can find a problem that you have some evidence that people other than your group of friends cares about, that's going to be likely to have more impact. Okay, so that's one thing about problem selection. Two is you got to make a bet, right? So, one thing you could do is define an area that you want to work on. But if you really want to focus people, a good thing to do is put a stake in the ground. And so the stake that we put in the ground for AMPLab is we're going to build a system that integrates algorithms, machines, and people. And if we can do that successfully, it's going to solve big data problems better than approaches that people are doing that aren't doing that integration. Okay, and that's our bet. And, here's the good news. If you're a person who works on computer systems, it's not all or nothing, right? If you come up with this bet, you launch in this direction, you might get there, you might not get there. But the good news is it's not like you're trying to, prove a theorem and you either prove it or you don't prove it. Okay, and if you don't prove it, you can't really get a paper out of it. In systems, you'll always be able to do something interesting. Okay, you'll always be able to, push the state of the art a little bit. You'll be able to do experiments and show. So, it's not that risky. Okay, you might guess wrong and kind of be heading slightly somewhat in the wrong direction, but you'll be able to get results out along the way, and that's important. It's important for students who are trying to graduate. It's important for young faculty who are trying to build their careers. But making a bet doesn't mean it's all or nothing. So it's not really a gamble. And then, again, we found that if you can get multiple people to work together, and especially if they're from different areas, that kind of shares the risk. And so it makes it easier to take chances. And, it's going to be easier to find new problems and new things to work on sort of in the boundaries between areas, right? Not, if you're in a well-established area, a lot of the low-hanging fruit has already been taken. Whereas if you can shift slightly, maybe in between some areas, you'll see that new problems open up. And if you want to be in between areas, it's helpful if you have people who understand both, all the different sides of wherever you are. And so that's why it's nice to get a bunch of people working together. And then, so really that's kind of the first set of lessons. Okay, problem that somebody cares about, put a stake in the ground, say you're going to do something, and then, our recommendation is to pick something that's not completely well established but spans some areas. And then put the team together to do that. Let me just build this out. So, sorry. Put Barney duck. So, you got to be realistic about, who you have around and what the strengths and weaknesses are. So you got to play, you got to think about that. You got to make sure it's something you're going to be excited enough about to work on for a long time, because these problems, if you pick something, sufficiently ambitious, it's going to take a while. Okay, and you don't want 2 years into it to decide it's not interesting. So make sure you're excited to work on it. And, pick a real goal and try to get as much as you can. I mean, it's hard to get faculty to agree on anything, as you know. But try to get some agreement on, a shared goal. And, what I said is, you want to avoid what's called Barney projects. So this is a cultural reference. So Barney is this purple dinosaur here. And he's a kid's, I think they finally, hounded him off the airwaves. But it was this kid's character whose theme song was, I love you, you love me. It goes on like that. And that's what a Barney agreement is. Everyone loves each other, but there's not like a lot of depth there. And so, you want to avoid that. You really want to try to come up with, a shared mission, and that'll keep, help keep things focused. All right, so what was our shared mission? We decided to build this BDAS or BDAS stack, and we spent, this is kind of a silly looking diagram, but we spent about a year coming up with this diagram. And they were not the most pleasant meetings in the world, as you could, everyone's got a picture. And before we drew this diagram, we were arguing about what systems architecture meant. So we spent 3 months talking about what systems architecture meant. And then we drew this diagram. So, it's, but it was good. We got everybody to agree that we were going to build something that looked like this, where you have, resources, people, machines, data. There's going to be some storage engine on the top. There's going to be query languages and other processing frameworks. But there'll be machine learning on top of that. And that would have some cross-cutting concerns in terms of dealing with answer quality and debugging and things like that. And so this was our template, really, for the first couple of years of the project. And like I said, it wasn't like we didn't do any work until we had this figured out. But while we were doing our work and everybody was doing things in each of these boxes, we were also on the side trying to reach some agreement about this. And I'll show you later how this, what this ended up looking like. Okay, another thing I want to mention, so that was about setting goals and agreeing on them. Another thing I want to mention is driving the work with applications. And this is a little tricky because you want applications to help you motivate the work, but you also want to be free to invent new things that maybe there isn't an application for. So you have to kind of balance that. But having applications is a great way to focus or inform the research, right? So if you're thinking about something purely abstractly, sometimes it's easier if you have a real situation and you can figure out if your idea is going to help with that or not. If you come up with something that solves some application, then you've got a nice proof of concept and you can demo things and you can show it to people. And you can also use that to evaluate alternative solutions, right? So it's useful for that thing. And here's the part that, it's hard for me as a nerd to believe, but there are some people out there, believe it or not, that care more about applications than the underlying technology. I know it's hard to believe, but it's true. And so if you want to get people excited about what you're doing, oftentimes, you can say, oh, well, I've come up with a new algorithm for, doing this sort of thing that, the old one used to be n cubed and mine's n squared. That's okay. Or you could have, a real use case that says, well, I want to monitor the traffic of an environment that has, 200,000 automobiles in it. And before I couldn't do it, but now I can. Right? Then people sort of can understand that. And then you drill into why. So, having applications is really good for getting people other than ourselves excited about what you're doing. So, having applications is important. So here's the applications that we started off in the lab. The traffic one I told you about, some crowdsourcing ones. I told you about the smartphone thing. An urban planning application, some cancer genomics work, and internet security. And, honestly, some of these have worked out better than others. So the traffic one was a big success, I think. The smartphone one I told you about. The urban planning one, we just haven't been able to make progress on that. Just the people involved and how it's working and the nature of the problem. And internet security, even though technically our solutions, I think, are really good for that, it's a question of priorities. That group has other things that they're looking at. And so that one hasn't gone as fast as I had hoped. Okay? But the important thing is, when we started the lab, we were trying to figure out, what's the killer app? What's the great app for what we're doing? And, we would come up with one of these and would say, well, yeah, but that, that has big data, but the data's structured. It's not messy. Or that one's got messy data, but there's not much data, and these sorts of things. And what we realized is, what you really want, you don't have to have a single application that tests every single thing you're doing. But if you have kind of a suite of applications, right, so those are our applications across the top. Those are a bunch of problems, that we want to have solutions for, along the side. And, if you kind of map out how the problems and the solutions meet, you end up with coverage of the space, even though there isn't one single killer app. And that seems to have been sufficient for us to start making progress. All right, so that's another kind of lesson is in addition to having a goal, it's useful to have some applications. And not only just applications, but people who own those applications that are willing to work with you. And in those places where things didn't work as well as we had hoped, it's because the relationship ended up not solidifying. So a lot of times when we work with an application group, we ask them to at least put a student or two into the lab, but hopefully to get the faculty involved as well. All right. Another principle is people. So I already talked about multidisciplinary teams. This is kind of a fun one. You want to pick the size and the members carefully, right? Because remember, you're going to spend 5 years with these people, or 6 years, or however long it is. And so, it doesn't take many tough personalities to make it to the point where nobody wants to work together anymore. And one thing we found, which is kind of funny, which is it's good to have one database guy. I get to be the database guy, So if there's a database problem, I get to sort of give my opinion, and it counts a little more than other people's opinion. And, whereas if there were 2 database guys, maybe it would be harder. And so, and I mean guys generically, people. So we found that it's useful to have somebody who's kind of an expert in, different things. And here's something that I mentioned earlier, which is whenever you start a project like this, especially if it starts acquiring, interest and funding, all of a sudden you get a lot of people who are interested in participating. And, the question is, how do you sort of decide who's in and who's out? And so over the years, one of the things that came up was what's called a 2 feet in versus 1 foot in model. And 1 foot in is sort of you're interested, okay? And maybe you're doing a project that's relevant to this bigger project, and so maybe, you can get support for a student or be involved in some other way. But that's kind of as far as it goes. The 2 feet in model says, when people ask me what I'm working on, I'm going to say this project, right? So when people ask me what I'm working on, I say AMPLab, okay? And 2 feet in is actually literal in our case. You actually move. You actually move into the lab, and I'll show you that in a second. But the idea is you try to establish, commitment from people up front. And basically, people who are 2 feet into the lab get a bigger say on what happens, and they, frankly, get a bigger piece of the resources, okay? And so, you could say that to somebody. Well, I'm interested in, this lab sounds really interested. I'm interested in big data. I'd like to work with you guys. And you say, great. Would you like to give up your office and sit in a cubicle with me? And if they say no, then you say, okay, well, maybe we'll support a student. And if they say yes, then they're, members of the lab. And it works really well, and you don't have long arguments. So this is just another interesting thing that I wanted to point out. This is one of the classic things that I don't know if it works anywhere other than Berkeley. But you say, if you want to be a full member of this lab, you give up your office, you move into the lab. And, okay, we can talk about that later. So space, again, I mentioned you guys have a wonderful space here. I was telling Bjord, this place is built for creating labs like this, so it's really great. But, we had to knock down a bunch of walls to do it. But the idea is, you have a shared space. The faculty are in there a fair amount of time. The students are in there a fair amount of time. And you run into each other. You try to have some space for social things. For those of you who are old enough, what's that, Space Invaders that we're playing up there? The space is really important, especially when you're trying to do multidisciplinary work, because people have to meet each other, they have to see each other, they have to be able to bump into each other and talk. And so, we do a few other things. I mean, obviously, if you don't have any walls, you have to have a place for people to have meetings. So we have lots of meeting rooms of different sizes around. And, the idea is if you run into somebody in the hallway and you start a good conversation, if it's going to go on for more than a little bit, you go into a meeting room. And so, that's one thing you have to do. try to have a lot of we try to have a lot of food and drinks around in the lab, so people, especially students, want to be there. And that's the idea, is try to get people to want to be there. So that's another kind of lesson that we've learned from doing these labs. So space is really important, and you guys, like I said, seem to be in really good shape there. All right, let me just give you kind of two examples of why this matters. So one of our most successful projects is this thing called Spark, which, like I said, is kind of an alternative to Map Reduce. And the way Spark happened is we have a bunch of machine learning people in the lab. They were trying to run algorithms on Hadoop, and the algorithms were running really, really slowly. And so they wanted to talk to some systems people about that. Well, how do you talk to a systems person in our lab? Basically, if you're a machine learning person, you sort of look at the person next to you, and you say, hey, by the way, do you know anything about this Hadoop thing? Because chances are they're going to be a systems person. So they went to the systems people. They said, hey, here's the algorithms we're running. Tell us what we're doing wrong with Hadoop. And the systems group looked at it, and they said, no, you're not doing anything wrong. That's just the way Hadoop works. And the problem is that Hadoop was built for a certain set of workloads, and what Hadoop does is it uses disk very heavily. So you store data on disk, you read the data in, you process it, and you write it out to disk. And if you want to process that data again, you read it in from disk again. Now, if what you're doing is one query at a time, that's maybe okay. It's not great, but maybe it's okay. But what these machine learning people were doing is they were running iterative algorithms that were going over the data many, 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 many times. And the way Hadoop was working is you read the data in, you iterate on the data, you write the data out to disk. Then you read it back in from disk, and then you iterate, and then you write it out again, and then you read, and so you understand. So basically, every iteration of that algorithm was going through the disk, which is about the slowest part of any modern computer system. Okay, so it's a bad idea. So the systems group looked at that, and they said, well, yeah, this is the problem, and we can solve this by not using the disk, okay, or using the disk less. Now, so that's what Spark does. Spark keeps things in memory as much as possible, and it does it, especially in an iterative environment, it does it, tailored for that environment. Now, that sounds easy, but it's not, because the reason Hadoop writes everything to disk is so that if a system dies, right, if one of your computers dies, you can get the data from somewhere else and keep going, okay? So it sounds trivial to put things in memory, but it's not, because you want to preserve the fault tolerance. And so what Spark did was figure out an interesting way to do that. I don't have time to get into it now, but that ended up being the Spark system. And, what you end up with is a system that for things like Map Reduce, for iterative algorithms, if you see on this graph on the left, the blue is Hadoop, and basically every iteration costs you the same. Whereas with Spark, you pay for the first iteration, and then the rest are all much faster. Okay, so for this type of workloads, we can show, in this case, sort of an 80 times performance improvement over Hadoop. Now, given how excited people are about Hadoop, if you could put that out as an open source system, you're going to get a lot of interest, and not surprisingly, we did. So that's kind of one example of something that probably wouldn't have happened if we had just had a systems project or we had just had a machine learning project. And maybe if we had had a systems wing and a machine learning wing, right? Maybe it happened because they happen to be sitting next to each other. All right. There's another one I'm not going to get into called ML-based, but basically this is a collaboration between machine learning people and database people. And what we're doing there is we're trying to make machine learning, which right now you have to have a PhD in statistics and be a 5-star wizard to use. We're trying to make it like using a database where maybe you only need a master's degree and be a 4-star wizard, right? So that's kind of the short answer there. But again, it's a collaborative project that we're doing. Okay, something else. This one might not be popular here. Labs have an end date. Okay, so you start the project. You say, we're going to have the opening ceremony on this day. We're going to have the closing ceremony on this day 5 years later. Okay, and that's kind of a radical thing to do. So why is that? So why do we do it? So, well, for one thing, that's about how long it takes to get a PhD at Berkeley. It's about 5 years. Okay, so that kind of works out well. things move so fast that, a problem that you come up with now is probably not going to be such a super interesting problem in 10 years, right? So 5 years is kind of, we can see 5 years in the future, but it's harder to see past that. So that's kind of a good reason to do it. If the project's not as successful as you wanted to be, well, it's not like it was a disaster. We had planned to stop it. So it's easy, if things aren't going that well, it's easy to get out of it. So that's good. And again, if you're making big bets, every once in a while you're going to bet wrong. So that's not a bad thing. And, the other thing is it avoids creating an entity that after a while loses its focus, right? And you forget why you created it. Okay, so it keeps everybody on a track. And, it gives you more things to work on. And so it's not like our group completely disbanded. So we had this project I told you about called the RAD Lab, which was a cloud computing project. We did that. We finished it. And then, we were talking about disbanding, but then we saw this big data thing happening. And so we said, well, let's create a new project. And we kind of switched the players around a little bit. I became the director of the new one. There was, but we really changed our focus. We came up with new goals. We brought in some new people. A couple old people left. And we started a new lab. So, that gives you a chance to work on a bunch of different things over time. So, just in in terms of concrete things lessons that have come out of this lab model, this is one of them, is have an end date. It's radical, it might work, it might not work. It seems to work really well for us for some reason. Okay, so here's the part that people wanted to hear. So we've got 21 companies, I think, now sponsoring the lab. So what do we do with them? So, we're really proud of our industry relationships, and we think it's sort of our unfair advantage. When we look at other big data projects, around the world happening at universities, we're a little smug because we have this tremendous support from industry. And so, we get a lot from industry. They give us, they tell us problems to work on, and sometimes we listen. They have insights that, we just don't have because they're seeing things that we're not seeing, and they're solving problems that we haven't tried to solve. We get guidance. They do give us money. They fund half the lab. And most importantly, or not most importantly, but very importantly for a big data project, they have data, right? We don't have data. We have to make up data, and if we're going to do stuff. So, we get access to data and problems. And so the way we work with the companies, by and large, is we have twice yearly retreats, okay? And I'll tell you about the retreat model, but that's the main focus of interaction. So twice a year, every 6 months, our lab gets together with representatives from each of the companies at the same time, and we give a deep dive on what the lab's been doing for the last 6 months, where we're going, what the roadmap is, and then we have a hard, frank discussion about, whether things are going well and what we should change. And that's the main source of interaction, okay? And this turns out to be a really effective way of working with the companies. So let me say a little more about this. So what do you get if you sign up to join the lab? So, I don't want to get into specifics here. I'm happy to share with the people running the center kind of, how much we charge and so on. But we have 3 tiers of membership, right? The founders, Amazon, Google, and SAP, a bunch of big companies that are our sponsors, and then a bunch of startups, who don't frankly give us that much money, but they do give us something. And so, you fall into one of those tiers depending on, where you are as a company and how much you want to work with us. And so what do you get, though, as a sponsor? So, okay, so here's the message I wanted to sort of get across to people who are thinking about working with the university. So university research is an incredible bargain. I mean, students work for almost nothing, right? Who are the students in the audience, right? You guys work for you're not even getting minimum wage, right? Professors are slightly above minimum wage, okay, but not a lot, okay? So if you want research done, it's going to be much cheaper to have it done at the university than anything you're going to be able to do in your company, okay? So that's one thing that companies get. Now, some people confuse that. University development is not a bargain, right? If you have a very specific thing that you need developed by a certain time, you don't want the university doing that. That's not what universities are set up to do, okay? So when you're a company thinking about working with the university, you know, you want to think about sort of what are things that are a little further out than what you're able to think about right now, and that's what you want the university to be looking at. Okay, and if they do that, it's really a cheap way to do it. They get early access to our ideas and our directions. So, you know, before we released Spark to the public, all our sponsors knew about it. They had gotten to play with early release versions of it. They gave us input into what they'd like to see in it and all that. And that's pretty valuable to some people. They help influence the work. I'll tell you a little bit in a minute about how they do that. You know, frankly, a lot of those companies, people are like, why are those companies members of your lab? Number one reason is they want to meet the students, right? Because it's an incredibly competitive hiring environment in IT right now. And companies are smart enough to know that, you know, they're not going to be able to grab students out of the lab right this second, but eventually those students are going to graduate. And wouldn't it be better if they already had a relationship that if maybe even had worked together a little bit before those students graduate? So it's a great recruiting tool, and a lot of internships happen and so on. So that's actually one of the big values, is access to students. You know, sometimes they care about talking to the faculty. And, you know, for the big sponsors, you know, periodically we'll go out and give talks and updates there. You know, otherwise people come to us for meetings and so on. So you get access to faculty. And then the other thing is, we were mentioning earlier, is you get to be part of this community, right? So I showed you all these companies, you know, companies that don't necessarily, you know, it's like cats and dogs. I mean, some of them don't get along that well. We're kind of a nice neutral place where people can come and meet and talk about sort of pre-competitive research, right, in this important area. And so a lot of information gets exchanged, and a lot of you know, a lot of contacts get made, you know, amongst the people in the companies, which I think they find quite valuable. Now, this is also pretty controversial, but what they don't get is any IP rights, okay, to our software. So, you know, we have 21 companies that sponsor us. If we had to make IP agreements with 21 companies, we would do nothing but talk to 21 teams of lawyers. and 22, because we'd have to deal with the Berkeley lawyers too. So, so we put everything out in open source that we can. And companies understand that. And it seems to work really well, okay? But what that means, if you're thinking about it, if you're thinking about saving a few dollars, you say, well, geez, you know, I don't really have to join that lab because they're going to put the software out and I can use it for free, which is totally true. Except if everybody does that, then there won't be any software coming out. So, you know, companies understand that, okay? And it seems to work really well. All right, so that's what sponsors get. Let me say quickly about the retreats, and then I want to sort of get to the conclusion. You know, we started doing retreats for a simple reason, which is it's better to have, for us, to have one big meeting than 21 small ones. And so we get everybody off site. In the winter, we go skiing. In the summer, we go off to the coast somewhere. And I'll show you what it looks like in a second. But it's, you know, 2.5 days of pretty intensive stuff. Students present their work. We have poster sessions. Let me see. Let me just build this, sorry. We have poster sessions. So students present their work. We have a lot of presentations on sort of different parts of what we're doing across all the different sub-projects. We have breakout sessions where, you know, especially at meals, we have a topic for each table to discuss. I'll show you what that looks like in a second. But the idea there is you set up different topics so that, you know, people from the companies realize that they should set one person at that table and another person at that table. Otherwise, you know, what will happen is people from the same company will sit at the same table and they'll talk about, you know, who just got fired or who just, you know, whatever, right? So we set up these breakout sessions to discuss interesting topics. We have poster sessions, so every student at least presents a poster. If they don't present a talk, they at least have a poster, and you can walk around and meet with the students. And that's really where the contacts get made. That's where, you know, somebody from a company sees a project that looks interesting, they talk to the student or the students who are doing it, and that's how the connections get made. So that's really important. And then at the end, we have the very last thing we do is we have a feedback session where a representative of each sponsor gets up and no more than 5 minutes says, you know, here's what we heard, that we thought was really great. Here are some things that you said that, don't sound right to us, based on what we've been seeing. And here's a bunch of things that we're really worried about that you guys haven't done anything on, and why don't you work on these? And we get that from each of the companies, and we do that every 6 months. And, we record those, and in the subsequent retreat, we talk about which ones we did and which ones we didn't do. Okay, so that's kind of how that interaction works. This is just some of from last January's retreat. We had 13 tables worth of people, and so these were the kind of topics that you could cover, and you could see, streaming in real time, how to use new hardware for analytics, and so on. And, the idea is, you just get people from all the different companies. Basically each table is kind of half sponsors and half lab people. And, you just talk about these issues, you write down some notes and so on. Okay, and we record all the summaries on a wiki. Okay, and so there's some usefulness in this too, but the main thing to do it is to get people who wouldn't not normally be talking to each other to talk to each other about something that they care about, together. Okay, so that's how retreats work. I already talked about I already talked about the Wired article with Twitter. This is Yahoo has been very vocal about how they've been using some of our software. A lot of companies are using the software and they're not that vocal about it. That's okay too. So we've had pretty good interactions. So let me just skip that. This is what the stack looks like now. Okay, and it's the important thing to see is we have resource management at the bottom, we have data management in the middle, we have data processing at the top. There's a couple things. Notice there's no crowd in here yet. There's no people. We're going to fix that. Okay. But the other thing to notice is all the very light stuff that's supposed to be white, but it's kind of this light blue. That's all stuff that we didn't build. Okay. That's all stuff that's third-party open source software. And it's important for us, for adoption, that we play nicely with all those things, because that's what people are using in the big data space. So HDFS is the Hadoop file system. Even though we think our stuff is better, a lot of people still want to use Hadoop. All these other, systems that people are using. And so, given that those are all open source and that their interfaces are all public, we can build our stuff in a way that plays nicely with those. And that helps our stuff getting adopted as well. Okay? So what you can see is if you squint, this picture looks a lot like that kind of cartoon one that I showed you before. Okay? But it's got more detail to it because we're now 2.5 years later and we've actually figured out what we're doing. And the dark blue stuff are things that we've released. The light blue is where we're going. Tachyon is a caching layer to make the file system run a lot faster. GraphX is a graph database that runs on all of this infrastructure. MLBase is the system I told you to make machine learning easier, and so on. So we're slowly moving up the stack. Okay. And I'm going to skip this, but the main thing is, I already made this point. Open source is a great opportunity to have impact. Okay, and especially if you can tie in with an open source project or ecosystem that has momentum, like the Hadoop ecosystem, which is what we did. We just latched right onto that. Okay, just to show you, we've gotten a lot of attention for this stuff. It's not just of academic interest. There's just some of the press mentions that we've had. And also it's interesting, Amazon, which is the main way that people get cloud resources in the US at least, actually has an option now when you go to their site. If you want to fire up a cluster, they'll automatically fire up a Hadoop cluster for you. Or if you check the right box, you can get them to fire up a BDAS cluster for you, although they don't call it BDAS. Okay? So, that's the way you can engage with kind of the outside world. It's really effective. All right. Oh, this is just another thing. We've been doing meetups about the software stack, and this is one we had earlier in the month. It's at Twitter headquarters in San Francisco. It was a discussion of the MLBase project, and basically we announced this thing. Twitter, bought the food and the beer and let us use their cafeteria. And we announced this thing. They told us we could have 200 people attend. Those slots filled up like on the first day or two. We extended it to 50 more, and then we had a waiting list of like 100 people. And so, if you give people free beer and you have it in a cool place and you're working on something people care about, I mean, big data has this magic aura about it now. If you say big data and machine learning, people will show up. And so you can have that kind of, build a community that way too. All right, and I'm going to skip that. So let me just wrap up, and I'll try to get you out in time. If you want to work on big challenges, we think that sort of the traditional way of doing research in computer science is too limiting. And so, we argue for sort of these collaborative projects with some interesting tweaks that we've kind of added to it along the way. I told you about, how we try to choose problems and how we organize the team and how, you have an end date and so on. The key thing, which you guys have already figured out, is collaboration and interaction with lots of people, other academics, people in industry, other people who have real problems and so on. And, that's, to me, the thing that's most exciting about this type of a center that you guys are building or the type of lab that we have. It's, you get this larger footprint where you get to have these interactions. And as was said, it's, the sum is greater than the total is greater than the sum of the parts, or whatever it is. But that's what I believe that. Okay. And then, pitch for open source again. And the other thing I just want to mention, because of the theme here, is that, these partnerships can be, it's kind of silly to say, but it's win-win. I mean, the academic side gets a lot out of it, and the industry side gets a lot out of it. And you don't have to, have things wired down. You don't have to have legal agreements of this and that, and it can be done in a fairly flexible manner and still get the benefits flowing both ways. And I guess if I was going to give any sort of one piece of advice, I guess that would be it, which is don't overthink the structure and the agreements. Software is this thing that likes to be free. Richard Stallman said that, and there's some truth to that. But this is an intellectual exchange, and you don't have to wire it down, to every last crossed T and dotted I. You should set something up and let it breathe, and then if things aren't working right, then adjust it. And we've sort of had 20 some odd years to do that, but I think that's the right way to do it. So just to wrap up, I just wanted to thank, these are my co-PIs in the lab. If you recognize any of them. Dave Patterson in particular, the scary guy, third in. He's the one who really pioneered this model and, has sort of been helping me run the lab a lot, giving me a lot of advice. We've had great sponsorship. And then finally, I just want to thank Bjord for the invitation and for you guys for inviting me. It's been a great visit. I'm really excited to see what you're doing here. I think you've got, a lot of great things ahead of you, and I'm looking forward to, keep working with you and keep in touch with you. So with that, that's all I have.